Now, if we look at and review how to factor polynomials that have 4 terms, if we go back to our factoring tree, so I common factor first. So it's not 2 terms, it's not 3 terms. So if it has 4 terms, then I'm going to group factor. So I can group factor using the 2 by 2 method, the 3 by 1, or the 1 by 3. And so we will show all 3 examples here, the 2 by 2, the 3 by 1, and the 1 by 3. So if we look at the 2 by 2 method of factoring, so I group the first 2 terms together and the last 2 terms together. And you don't have to write this down when you're doing it, but just as a mental note, you're chunking these 2 together, and the negative goes with the second term, right? And the next 2 terms together. I'm going to look and find the GCF only of that group of 2, each separate group, and then common factor out the binomial overall. So if we take a look at this example, if I only look at these 2, and I'm trying to find the GCF, well, X and Y are not common, so I have a GCF of 5. And if I have a GCF of 5, 5x divided by 5 would leave me with x. Negative 5y divided by 5 would leave me with negative y. So now I need to find what's common in terms of my second grouping here. So I have negative ax plus ay. So the x and y are not common. So I have an a, but I have a negative a and a positive a. So it might be a little bit confusing. You're thinking, well, should I take out the negative or should I take out the positive? The best answer to that is take out whatever you'd like to first. So let's say the negative a, and I'll show you what I mean. And you'll know if it's right if your bracket here is exactly the same as this bracket here. And if it's not, then you know that you just take the opposite sign out. So for example, if we take negative a as our GCF, negative ax divided by negative a would leave me with the x, right? And just to show ay, right, divided by negative a would leave me with negative y. And wait a second, that's what I wanted, was the negative y, because I want these 2 brackets to be, they should look exactly the same as each other. So that works. So taking the negative a out instead of a positive a was the right thing to do. So then what I'm going to do is common factor the binomial overall. So because this is a common term, x minus y and x minus y, that's my common factor. And then in the second bracket, I write what has not been taken out, what is not a common factor. So here 5 was left over, and here negative a was left over. So my final answer is x minus y in brackets multiplied by the binomial 5 minus a. So what if it was 3 by 1 factoring? What if I had a question, for example, that looked like x squared plus 6x plus 9 minus y squared? So it would look basically in that order. It has to be a perfect square trinomial. That is the first 3 terms. So I'm going to group the first 3 terms together. So kind of mentally in my head, I'm looking at these 3. And it has to be a perfect square, meaning the first term, can I square root x squared? And can I square root 9? And in this case, I can, right? Square root of x squared is again x. The square root of 9 is 3. So far, so good. The single term remaining at the end must be negative, and it has to be squared. So again, if those rules don't come into play, then I can't do this 3 by 1 factoring. So how do we start? Factor the perfect square trinomial using the perfect square method we just did in the last video. Then we're going to do difference of squares factoring to take care of the last term as well. So the first trinomial here, perfect square trinomial, would be square root of x squared is x. Square root of 9 is 3. Take the sign from the middle and then square it. Now again, we double check that by multiplying these 2 answers together, 3x, and doubling it, 6x. And we make sure that that middle term is double the multiplication of these 2 terms, right? Just to double check that it is a perfect square. And then we simply copy down and bring down the negative y squared. So now we're at, let me just change the color here. Now we're at this step here. So we factored the perfect square trinomial. Now we're doing difference of squares factoring. So the difference of squares factoring is at this step. I have two terms. This is one term. This is two terms, and there's a difference in between them. And again, difference of squares factoring is also only if I can square root the terms. So going back here, what is the square root, for example, of x plus 3 squared? The square root and the squared sign go away, and I'm left with 1 binomial of x plus 3. And what's the square root? Again, don't worry about the sign, but y squared would be y. And I take these two answers to write out my binomial. So again, make your brackets a little bit wider apart this time because you're going to have 3 terms in each bracket. So I take the answer to the first perfect square. When I take the square root of it, I get x plus 3. So the entire x plus 3 goes in the front of both brackets. And then the answer to the square root of y squared, which is y, goes on the end, the second term of both brackets. And again, one is positive and one is negative. So I end up with an answer of x plus 3 plus y multiplied by x plus 3 minus y. And again, that bracket could go first, this bracket could go second. And can I go any farther? I have an x, a 3, a y. There's no like terms here. So I'm done. What if it was 1 by 3 factoring? Basically looking the same way, but in reverse order. So what if the example here was x squared minus 6x minus 9, and I had the y squared minus out in front? So group the last 3 terms together. It also must be a perfect square trinomial, but once the -1 is factored from the first 3 terms. Factored from the 3 terms of the trinomial. So here, this is grouped together. Now there's a negative sign in front, but like this step says, I have to factor that negative sign out. The single term at the beginning must be squared. So same rules here as before. Factor the perfect square, then we'll do a difference of squares here. So to factor the perfect square, let's do the first step here and factor out the -1. So y squared, take out the negative, and I'm left with x squared plus 6x plus 9, right? And you can double check that. If I bring the negative in, I would get -x squared, -6x, and -9, which would get me back to the beginning. Then I want to factor, perfect square factor, this trinomial term. So now I have y squared minus, what's the square root of x squared? What's the square root of 9? Take the sign from the middle. That should be a 3. Let me see if I can just erase that. Perfect. And the squared on the outside. And again, 3x doubled is 6x, so it does work. And now we do the same thing as before. We do our difference of squares. I have one term, a difference, a subtraction sign, and another term. They're both squared, and they're both perfect squares. So if I were to square root them, the square root of y squared would be y. I would put that at the beginning of my bracket. And again, the square root of x plus 3 squared, right, would be x plus 3. And one term is positive and one term is negative. So let's put a negative here and a positive here. But the problem is it's subtracting this entire second term. So this term has to have brackets around it. So then I should multiply that negative in using distributive property. Bring that -1 times x and that -1 times 3. Here you're adding. You could put a bracket in, but if you multiply in the positive sign, it doesn't change anything, right? So then my final answer here would be y -x -3 minus 3 multiplied by the y plus x plus 3. And again, if I take a look just as before, I have a y, I have an x, I have a number. There isn't any like terms here, so that's as far as I can go with that type of factoring. So there's an example of 2 by 2 factoring, 3 by 1 factoring, and 1 by 3 factoring.